All right, y'all, welcome. It's Miss Skelton here. I'm sorry I can't be with y'all today, but you're still going to be able to learn and explore some without me there, and you do still have a quiz today also. So the first thing you're going to do is go to Canvas, and I've put a link to an exploration on Desmos. If you don't have your own device, you can share with a neighbor, and that's completely fine. But what it's going to do is it's going to give you a function, and it's kind of a crazy looking function that's graphed as a half circle. And then there's a bunch of lines of different equations, and you're going to go through and click each one. There's a circle next to it, so when you actually click that circle, it's going to fill it in, and it's going to graph the same function, but it's going to make a change. So some of the changes are in parentheses with x, some of the changes are in front of f of x, and you're going to kind of make note of how this half circle changes. Tell me, does it shift to the left or the right? Does it shift up a certain number of units? Do the x's or y's get affected? So you're going to spend the first 10 to 15 minutes just exploring how numbers in an equation affect a graph. So now the video can be paused for you to do that, and we're going to come back and summarize our findings afterwards. Okay, so hopefully you did your exploration and kind of saw the different patterns when we put numbers in the equation. You need paper for notes. We're going to summarize those findings, and I'm going to show you how I will ask you questions about transformations in the future. So take a second to write down this function, f of x, and then there's an a value, a b, x minus c, and then a plus d at the end. Okay, so the first thing I want to talk about is this a value here. So this is when you saw something multiplied in front of a function, and I'm hoping that you saw it made the graph get stretched or compressed, and it's going to do that vertically. So multiplying by a 2 or 3 or 4, talking about your original graph, it should have then stretched it and made it a much narrower graph. So A can do several things. First of all, let's talk about if it's negative. If A is less than 0, meaning it's negative, you should have seen the graph flip over the x-axis. So I'm going to put reflect over x-axis. If the function gets multiplied by a number bigger than 1, so here I'm going to write the absolute value of A is greater than 1. I'm putting absolute value here to make you ignore the negative. So absolute value makes a number positive. We will just look at the number, not the negative sign. And this is what we call a vertical stretch. So I'm going to go ahead and put V for vertical, and then I'll use H for horizontal. Now, if that number became smaller, so if you saw a fraction there instead, then that graph vertically is going to get compressed. It's going to look wider, so we're going to call that a vertical compression. I'm also going to be identifying the scale factor, how much it gets stretched or compressed. In Unit 1, that's not our huge focus, but the scale factor here is going to be your A value. So it'll get stretched by a 2 if there was a 2 there, or compressed by a half if A was a half. Okay, now you might have noticed in parentheses, if there was a number there multiplying by x, it also made changes of dilations, stretching and compressing. But these changes are actually horizontal. So anything here with x are horizontal changes, And then hopefully you kind of noticed that they were the opposite of what you might have thought would happen. So for B, if B is negative and less than 0, this is a reflection over the y-axis. So flipping horizontally instead of vertically. I'm going to use absolute value again. If that value is greater than 1, it actually creates a horizontal compression. So notice that's the opposite of what just happened with our vertical change. If that value is between 0 and 1, then I have a horizontal stretch. And the scale factor, because everything here is opposite, the scale factor is actually the reciprocal, or 1 over that B value from the equation. We're going to do more with numbers in just a minute. So keep writing it down. I promise we're going to practice still. Okay, C and D were the shifting of the graph. So two things could have happened. If that value is with x, it's a horizontal shift left and right, and it's the opposite of what you would think. So if you saw x minus a value, it is shifting the graph to the right. So minus shifts right, while a plus sign was a horizontal shift to the left. Okay, so again, everything with x was opposite there. Now, the final value that I could change here is adding or subtracting a constant at the end. So I'm hoping that you noticed adding a value shifted the graph up or down. So adding shifted it up. So I'm going to put vertical shift up, and minus a value was a vertical shift down. Okay, great. So this is a summary of all the ways we could change an equation. It's important that we start thinking about these in the right order. So the order that these operations happen on the equation matters. The first transformation that always happens are all reflections. The second one are all of our dilations, the stretching and compressing. So kind of think of order of operations. All of the multiplication comes first, and then the final thing that would happen would be all of our translations, our adding and subtracting that shifts the graph. In Unit 1, I'm not going to take off if you put them in the wrong order when we list them in a second. But after Unit 1, I will start taking off if we don't put the transformations in the right order. Okay, so how is this going to look? Well, let's do some examples. So the first ones I want to do are actually going to be in function notation. And I want you to list all transformations from f of x to g of x. So on these two examples we're going to do of this type, I'm not going to tell you what type of function it is. You're not going to know if it's a square root or quadratic. It doesn't matter. So here's our first example. G of x equals 5 times f of x plus 1 minus 4. Okay, so the first thing I always look for are if I have any reflections. So I'm going to look for a reflection in front with my A value. If it's not negative, there's no reflection. Then I'm going to go look with my x's. Since there's no negative with x, there's no reflection there. Okay, great. I'm going to think of these as two different types of transformations, horizontal and vertical. So everything horizontal comes from the x in my equation. Everything vertical would come from a and d at the end. So this x plus 1 here horizontally is going to shift the graph the opposite that I would think. So this is going to shift the graph left 1. We'll talk more of the why behind that next class. And then the vertical changes, I have my 5 and my minus 4. So this a value is greater than 1. That means it's a vertical stretch. And the scale factor is 5. Whatever this graph looks like, it is being stretched to increase or decrease 5 times as fast. The minus 4 at the end is a shift up and down. So this one is specifically down 4 because of the minus 4. Okay, I want to make it a bit trickier. And I can do that, well, you'll see. So g of x, so I guess I didn't make this clear. F was the original function, and g means, hey, we did all of these transformations to some original function f. So for our new function g, I want to talk about what happens if we make it negative 1/3 times some function of 4x plus 8. We're going to decide what's horizontal and what's vertical. So everything horizontal is going to be with x. Maybe we'll start with that. Notice this looks different than what we put at the top. Here, b is separate from x minus c. So we have to do the same thing if we see a number with x. We have to factor, I know that's your favorite, factor out of 4, and it leaves x plus 2. I divided the 4x by 4, the 8 by 4, and this separates out my b value from my c value shift. You have to do this or else you will get your shift wrong every time. Okay, so horizontal, these are my two horizontal changes. Everything with x is opposite. So a number bigger than 1 here is actually a horizontal compression, and you can abbreviate that. The scale factor is going to be the opposite of what you would think, 1/4. So from side to side, this graph gets compressed so that it's 1/4 as wide. The x plus 2 is a horizontal shift. It's going to go the opposite you would think, so it's also going to move to the left like the last one, but just by 2 because I factored out that 4. Okay, the only other number I have to look at is this negative 1/3. The fact that it's negative means I have a vertical reflection over the x-axis. And then the 1/3, ignoring the negative, 1/3 is my scale factor of my vertical compression. It is a compression because 1/3 is smaller than 1. So a vertical compression with a scale factor of 1/3. Notice I didn't put negative 1/3 there because the negative reflects it. The 1/3 is the scale factor. Okay, we are going to do 2 final examples. And this time I'm going to make them an actual function. This is going to be what your assignment will look like. So let's see. Example 3, f of x equals negative 3 times negative 2x plus 6 squared plus 1. Okay, this is no longer written as g in terms of f. This is an actual type of function. So this squared here is my indicator of the type of function. This is a quadratic because of the squared. The parent function, hopefully you remember from last class or Algebra 1, is y equals x squared. Okay, so we're still going to be thinking about the horizontal and vertical changes. I'm still going to start horizontal. Start with my x's. There's a negative 2 with x, so I'm going to factor this out. And it leaves x minus 3 when I divide both of them by negative 2, showing me my b and c values. Notice I didn't actually square this binomial here. The squared only tells me the shape of the graph. The squared means this is a parabola, a U-shaped graph. Now we're just focusing on inside the parentheses and outside the parentheses for my changes. Okay, so looking at this that we just simplified, I see b is negative, so right away that's a horizontal reflection over the y-axis. If you just write horizontal reflection, that's fine. The 2, well, everything with x is opposite, so this is a horizontal compression, and that scale factor is the reciprocal of 1/2. The third change I see is x minus 3. Remember, that's going to shift the opposite, I would think. It's going to shift to the right 3 units, and it's fine with me if you notate that with just R3. Or if you want to write out the word right, that's fine. Okay, the vertical changes mean I have to look at A and D. A is negative, so I also have a vertical reflection over the x-axis. The 3 itself means my graph is vertically stretched because it's bigger than 1, not looking at the negative. The scale factor would be 3. And the last vertical change would be the +1. You can write U1 or up 1. So when we get to this unit, it's going to help us sketch a graph of this function without a calculator because we're going to know how the x's and y's get changed from the parent function. But right now, all you have to do is identify from an equation what those changes are. Okay, one final question that I'd like us to do, and we will go over this more next time. So don't freak out if it feels like overload right now. Okay, I want us to do 1/2 times the square root of 2x minus 4 plus 3. Okay, notice this time I switched it up. Instead of quadratic, writing the square root means that this is a square root function, and I look under the square root to see my horizontal changes that are with x and are all the opposite of what I might think. So let's start with horizontal. I need to separate out the b value by factoring out a 2, and it leaves x minus 2 when I divide each part by 2. Okay, so the 2 here means I have a horizontal compression. You can refer back to the summary we made on the page before. The scale factor is the reciprocal of 1/2. And then x minus 2, a minus means we are shifting the graph to the right. Oops, there we go. Vertically, I'm looking at A and D. And the 1/2 means I have a vertical compression. The scale factor here is the number that I see. The +3 at the end means I'm shifting the graph up 3 units. No reflections because A and B were not negative. Okay, so on today's assignment, let me show you really quick. Here's the worksheet you're going to get, and it is part of your retest requirements. However, there's a lot on here that we're not going to do. I want you to make it your goal, because of what I'm going to ask you on your first test, to just do a verbal description of all of the transformations from each function. So I want you to tell me what type of function it is. You could put that maybe up here. And then under verbal description, I want you to go ahead and make your horizontal vertical chart with the changes to the X's and the Y's. You do not need to fill out these tables or the graph or the domain and range. I know I could have reprinted it to look differently, but this is what you have to know for your test. The function type and the verbal description. We will get to all of this in our later units. Alright, y'all, I'll be back tomorrow if you want to come by before or after school for any tutorials, and I promise we will go over this and I'll answer any questions next time on our review day. Alright, see you then.